All right, let's see. 10, 23, 13, and chapter 9, section 2, reflection. For those of you that are in Avid and you need a focus question for your notes every day, don't write the one down that's on the board because it hasn't changed in about a month. In each section, when we start it, there's a focus question right on the first page. Okay? Is there anybody in here that needs a focus question in their notes every day? Well, I'm glad I shared that with you then. All right, we're going to talk about reflection. That's, we're going to say to move a figure over a line. To move a figure over a line. Then you've got what's called a line of reflection. That's the line the figure is reflected over. And then every reflection is an isometry. You remember an isometry is when you move, when the two shapes are congruent, right?
Wait, what's
when the before and after are congruent. Say that again?
I was just asking what section it was.
Okay.
But it's 9-2.
Remember, an isometry is when the pre-image and the image are congruent, right? The before and the after are congruent. All right, so today, and right now, I wouldn't try to write what I'm getting ready to write because I've got graph paper, and if you try to draw a coordinate plane and put everything that I'm doing on your paper, you're not going to hear anything I say, and I think you're going to be confused. But if you just watch, what we're doing isn't that difficult. And if after you watch and I talk about it, you still don't understand it, you think you need to write it all down, then when you go home tonight, watch the notes and you'll be able to hit pause and you can do it then. Does that make sense?
Yeah.
All right. It doesn't? Well, if it doesn't make sense, then watch the notes tonight and maybe it'll make sense then. All right, what you're going to be asked to do today is to take a shape. Well, first you're going to be asked to take some points. If you connect those points, you're going to get a triangle, right? And reflect them over a line. The lines you're going to reflect them over today could be the x-axis, could be the y-axis, could be any other horizontal or vertical line. So if this triangle has points A, B, and C, and you're asked to reflect the triangle about or across the y-axis, okay? You're going to reflect it about or across the y-axis. The y-axis is this vertical one, isn't it? And this is your x-axis. That means you're going to take this triangle right there and you're going to pick it up and you're going to flip it over and you're going to put it on the other side of the y-axis. Okay? Like a piece of pizza. You're just going to flip it over. So what that means is that all these points, A, B, and C, their image, A prime, B prime, C prime, has to be the same distance from the y-axis. Okay? So let's start with B and let's reflect point B. How far is B from the y-axis right now?
10.
It's 10 units, right? So we got to go 10 units to the other side of the y-axis, to right here. And that would be B prime, wouldn't it? Okay? If C is 25 units to the right of the y-axis, how many does it have to be to the left? Okay, so it'd be right here, right? And that's C prime. And then if A is 20 to the right, it's got to be 20 to the left. So right there would be A prime. And you're going to be asked to list the coordinates of those points once they get translated across or about the y-axis. So B here would be -10 and 10. And A would be, and C would be, okay? And if you connect these points, then that would be a reflection of the image about the y-axis. Does that make sense? Okay. If you had to reflect the image about the x-axis, now you're going to flip it down, correct? Okay. So point C, which right now is at 25.5, is going to be at 25. Good. There's your C prime. 25, -5. A, which is at 20, is going to be at 20, -20. And B prime, which is at 10, is going to be at 10, -10. Okay, so those are the points reflected individually, and then if you connect them, you've reflected the whole shape. Okay, simple enough? All right.
It looks like a face.
Don't get me off task, please. All right, the other thing you're going to get asked to do today is to take a shape or some points and, no, it's not going to be a circle. Let's say you got X, Y, Z. And you get asked to reflect it about, let's go about X equals -10. Reflect it about X equals -10. Now, X equals -10, what kind of line is that? X equals -10, what kind of line is that? A vertical line through -10 on the x-axis, isn't it? Okay? It's a vertical line through -10 on the x-axis, so it sits right here.
So you gotta flip it over that.
That's your line of reflection now. Okay? So if they ask you to reflect it about the y-axis, well, the y-axis is your line of reflection. But if they ask you to reflect it about anything else, then that becomes your line of reflection. Alright? Just remember, x equals lines are vertical lines, and y equals lines are horizontal lines. So now, Z prime, if you're reflecting it over this line is x equals 10, then you can go here and you're going to go 10 units to the right of the line of reflection. Agreed? So if you're at -20, 10 to the right puts you at the line of reflection. You got to go 10 more right here. Okay, so that would be Z prime. All right, for your X, you are 5, 10, 15, 20 to the left of the line of reflection. Agreed? So you got to go 5, 10, 15, 20 to the right. Okay? And that would be x prime. And if y is 5, 10, 15 to the left of the line of reflection, how many do you have to go to the right? 5, 10, 15 to the right. And that would be y prime. And that's the points individually, and if you connect those points, then you've reflected the shape about the line x equals -10. Anybody confused? Let's reflect it. This will be, I want to do this. I've been wanting to do this all day. Let's go about y equals 15. If we reflect it about y equals 15, well, isn't this going to be your line of reflection? Y equals 15? So look, the point y is 5 units below it, isn't it? So where does this reflection have to be? 5 above it would be right here. So we'll call that y double prime. Double prime. We've already got a y prime. If z is 5 units above your line of reflection, it's got to now be 5 below it. Okay, so there's your z double prime. And if x is 5, 10 units above your line of reflection, x double prime has to be 5, 10 units below the line of reflection. Alright, and if you connect that, okay.
Was this the confusion?
Some people got confused there because it's flipping over, but it's not really moving horizontally or vertically. It's kind of coming up, flipping over, and going back down on top of itself. So sometimes that can be confusing. And to me, it's really easy to do when you're looking at it on a piece of graph paper. But today, when you do your assignment, you're going to have an image that's on the graph paper, and they're going to ask you for the values or the coordinates of the vertices once they're reflected. So a lot of people try to do it in their head, and sometimes they get a little bit confused. It's much easier if you just draw it on a piece of graph paper or on a piece of paper, put in your axis of symmetry, and then you can determine how far each point is at the beginning from the line of symmetry, and then you can reflect it. But what happened, if you can remember this, it makes everything a lot easier. When you're reflecting something vertically, none of its x values change, do they? See how all these x values, this is at -20, that's at -20. The y's are both at -25, and the x's are both at -30. Right? Whether you're flipping it over this y equals line or over the x-axis. And the same holds true if you had to flip this black image over the y-axis to the red image, or I'm sorry, over this x equals 10. When you flip something left to right, what happens to all the y values? The y values stay the same, and only the x values change. So each time you're doing these reflections, there's going to be a set of values that don't change, either the x's or the y's, depending on if you're flipping it vertically or horizontally. Does that make sense? Okay.
That's all we're doing.
Yeah. Yeah, they're going to ask you, you're also going to get asked, let me put this line of reflection in real quick. Yeah, let me finish. Look, here was the line of reflection, right? That was y equals 15. That was y equals 15. Okay, if I take a line and I connect corresponding points. See it? What's the relationship between the green lines and the purple line?
Oh, they're all like perfectly perpendicular to the thing. It's like
They're all perpendicular to the line of reflection, aren't they?
then it's like the same distance above the line, the same distance below.
So what's that called? Nice call.
Symmetry.
Close, but hey, remember this? Isn't it a perpendicular bisector? That piece is congruent to that piece, and they intersect at 90. This little piece is congruent to this piece, and these two intersect at 90. And this is congruent to this, and they intersect at 90. So a segment connecting corresponding points, its relationship with the perpendicular or with the axis of symmetry is it's a perpendicular bisector. Okay? That make sense? Can you remember that, you think? Good. Try to remember that because it's a question in your assignment today. Any other questions about reflecting images or points?
Let me guess which page. Page 573.
Good. You're going to do, since we don't do much in here,
7 to whatever. Whichever you want to do.
we're going to do 1 through 37 today. Yeah, we're going to kick it up a couple notches.
Whoa. Hey.
Because we don't normally do anything in here, so we're going to start doing stuff.
That was you.
It's alright. There's your assignment for today.
She's not even here to do it, so I feel like that's not her.
Oh.
Keep it.